With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us try to solve the given problem. So the given problem is said a student is performing an experiment using resonance column and a tuning fork of frequency 244 Hz. He is told that the air in the tube has been replaced by another gas. Now he was performing a resonance column experiment with a tuning fork and air was filled in it, and now he has been told that the air in the tube has been replaced by any other gas. Assuming that the air column remains filled with the gas, if the minimum height at which the resonance occur is 0.350 plus minus 0.005. So if the minimum height of the gas column will be this much in between these values, only then the resonance will occur. Now we have to find the gas in the tube. So which gas is filled in the tube? So we have been given some useful information also we will use in the question. So this is under root 167 RT is 640 joule per mole, and under root 140 RT is 590 joule per mole, and the molar mass in grams are given in the option. Take the value of 10 upon m for each gas as given in the question. So this is 7 upon 10, right? Now let's try to find out, but before we need to know that the minimum length required for the resonance is L minimum required for the resonance is 0.350 plus minus 0.005 meters. What is the meaning of this? It simply means that if the length of the gas is simply 0.350 plus 0.005, which means 0.355 meters or 0.345 meter, right? If we take the minus sign, it will be 0.345 meter. So the gas which will give this length, right? So the gas which will give this length, right? That gas will be giving the resonance with the tuning fork of frequency 244 Hz. So now we have to find the length of the air column for different gases. That is, up to what height these gases, up to what minimum height these gases can produce resonance. So how do we find that? We know that N is equals to V divided by 4L, right? So from here what we know V is equals to under root gamma RT divided by M. So if we put the value and we find for, so you can see that this is the formula for length of the gas column required for resonance with this tuning fork for different gases. Now we can substitute the value of different gases. So let's first try to find out for neon. Let's try to first find out for neon. So for neon we can substitute all the values. So length, minimum length for the required for the neon will be simply equals to 1 upon 4 into this is 244. Now neon is simply a monoatomic gas since it is an inert gas. So the gamma for it will be 1.67. We will not put the value of RT divided by M. Now here molar mass is simply in gram. So we need to convert that into kilogram by dividing by 1000. So that will go upwards, right? So now let's see. We can write it like this: 1 upon 4 into 244 into 16, we can write it like this: 167 RT into 10 divided by M. Now you can see here we have been given the value of 167 RT is equals to 640, and 10 by M we have to take equals to 7 by M. So if we find the minimum length required by the neon for the resonance with this tuning fork, it will come out to be simply equals to 0.459 meters. Right? So if neon is filled up to this 0.459 meters of length in an air column, then only it can show the resonance. But you see that the minimum length required for the resonance with this tuning fork is 0.355 or 0.345, between these values. So neon will definitely not produce resonance with this tuning fork. Now let's try to find out for different gases similarly. Let's try to find out nitrogen. Now we will directly put the values for nitrogen. So if we put the values, this is 1 upon 4 into 244. Now nitrogen is a diatomic gas, so its gamma will be 1.4 RT into 1000. You can see, since we molar mass is in gram. So now if we solve for this, again you can see that the value of 10 divided by molecular mass is 28. If we put the value, so what we are going to get, we are going to get the minimum length for the nitrogen will be simply 0.363. Now you can see that this is also greater than the minimum length, right? 0.355 and 0.348, right, meters. So nitrogen will definitely not show resonance. Now let's try to find out for oxygen. So the minimum length for oxygen, with the same formula, we are going to use 4 into 244 into, now oxygen is also diatomic gas, so we will have 140 RT into 10 divided by the molecular mass of oxygen is 32. So if we RT, so if we solve for this, what we are going to get, we are going to get 0.340 meters. So you can see that the minimum length required for oxygen for resonance with the tuning fork of 244 Hz is 0.340, but we required the minimum length of 0.345 to 0.355. Now let's try to find out for the argon. So for argon, if we directly use the same formula, argon is again monoatomic gas. So if we find out the length for the argon, it will be 0.348 meters. So you can see that this is the length which is in between this length 0.345 and 0.355. So only argon is filled in the gas, then it can produce resonance. I hope you understood the explanation. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.